we want to look at surface area. And when we're talking about surface area, we're talking about the area of the entire outside part of a figure. Now, looking at this cube, we have what is called the lateral surface area, which is meaning if I look at it from the side, it is talking about the lateral faces. So all the faces that you can see just looking at it from the side without rotating it, not the top or the bottom. Now, the entire surface area would include the bases as well. To consider a cube, we want to look at what's considered the net. This is what is considered a net. We have unfolded the cube to look at it. And the reason why we do that is so that we can see all of its sides. If I were to fold this back up, it would look like this cube. When we are talking about surface area, I want to find the area of each of its sides here. And so I want to find the area of this side, which is one of its bases. I want to find the area of this side, which is another base. And then I want to find the area of its lateral sides. So this, if I found the area of the surface of the lateral surface area, would be all the sides, and then these would be the bases. And so added all together would be the entire surface area. Now, a cube, the nice thing about a cube, is all of its sides are of the same length. So if you think about it, this has length of S, this has length of S, this has length of S, this has length of S. So each of these sides, whether it's a base or it's a lateral side or anything, has an area of an S squared. So this is S squared, all of these are S squareds. And if I count those up, that's 4, 5, 6. So the surface area of a cube is going to be 6 times the length of a side squared. Now, if I look at a rectangular prism, I have to be a little bit more careful because I no longer know that each of these sides are the same length. I have what's considered the height, I have the length, and I have the width. Well, these two sides are the same. These two sides are going to be the same because they're opposites of each other. And then these are going to be the same. Because if I think about it, the green is going to be length times width, length times width. So I have two length times widths. Then my blues will be a height times the width, height times the width, so I'll have 2 height times my width. Then these two red ones will be a length times the height, so that's 2 length times height. Now, it can also be written, if you think about it, I can also look at the perimeter of a base. If you think about it, the perimeter of this base here is the same as the length of this entire rectangle here, because it would be 2W and 2L. And I could take and find the area of this big O thing, so that would be H times the perimeter plus 2 times the area of the bases, which would be capital B. So you could technically look at the area of a rectangular prism in either way here. I prefer to look at it this way. It's a little bit easier for me to see. But again, it's whatever your choice is. The reason why we kind of look at it in this way is when we look at things like a rectangular, or I'm sorry, a pentagonal prism. Okay? With the pentagonal prism, we have to look at, I have this right here, and that's going to add up to the perimeter of this base. So again, P is going to be the perimeter of the base. And then we have our height. So we have H here. So we have perimeter times the height. And then we have 2 bases, area of the bases. And that area of the base depends on what we've studied in the past as far as here, because if you recall, with the pentagon, remember we drew those right triangles, and we had 1/2 of this height here times the base, and then we multiplied it by the number of sides. And so we can look at that prism, any prism, whether it's a rectangular prism or a hexagonal prism or whatever, we can use this perimeter times the height plus 2 times the base. Now let's look at the surface area of a cylinder. Now, the bases here are circles, okay? And we have that they have a radius of r. So the circle, remember, has an area of 2 pi times the radius squared. Or actually, it has pi times the radius squared. And then we have 2 of them because we have the top and we have the bottom. Now, this right here is not just a rectangle. Yes, we do have the height of it here, but to find the side, it is based off of the circle. It's basically based off of the circumference of the circle, because that's how far around it is. That's the length, because we're looking at the perimeter of whatever our base is. So if you recall, the circumference of a circle is equal to 2 pi r. So this is 2 pi r, and so then we have 2 pi r times our height. So this is the area of the circles. This is the area of the interior here. And we add them, because I have 2 circles, and then I have one of these. Now we have a right square pyramid. So we have to take into account the base, whatever the base is. So we have our base, area of that base, plus, and we have to look at this length here. Remember, these are triangles. And so this is not necessarily our H. Our H is the height of the pyramid. This right here is what we consider L. It is the slant height. Okay, so if we measure from the bottom to the top along the actual height. So this is like if I go from top to the bottom along that side. It's not straight from the bottom to the center down here. It's along this side. Okay? So this is going to be L, and then we're going to have the base here. And so we have the area of this triangle, which is 1/2 the B times the slant height. And in this case, we have a square, but maybe we have a pentagonal or a hexagonal or whatever. And so we're going to say plus n, and n is equal to the number of sides. So however many sides we have. In this case, we have 4, so that would be a 4 there. Now a cone. A cone, we have to think about the circle. Think about an ice cream cone. It's not filled in. We're just looking at the outside of it. Okay, so we have to think about the circle. And so we have radius of r. So that's going to be pi r squared. That's the bottom part. Plus, and then we have this here that's like a pyramid. And so we have to look at the slant height. So that's that L, which is this. And this way around it. So it's going to be pi r times that slant height. Some of these, you're just going to have to be able to look at the actual formula and be able to plug in. Okay? The surface area of a sphere is the outside of a ball, and that's going to be 4 pi r squared. So in the next video, we will actually use these to practice.